Welcome to Dystopian Bot Rise, where we explore the fascinating industrial journey transforming raw green cane into pure white energy crystals. It begins here in nature, where photosynthesis works its magic, storing solar energy as sweet juice inside these tall, fibrous stalks. Farmers carefully monitor the crop, waiting for the precise moment when sugar content peaks, signaling that the harvest season has arrived. Sugarcane is one of the world's largest crops by production volume, covering millions of hectares to satisfy our global sweet tooth. The tranquility of the field is broken by the roar of heavy machinery as modern harvesters prepare to work the land. Sharp rotating blades slice through the tough stalks at the base, separating the cane from the earth in a split second. Inside the machine, the long stalks are stripped of their leaves and chopped into smaller billets, ready for transport to factories. The chopped cane is ejected in a continuous stream into waiting trucks, a synchronized dance between two massive pieces of equipment. Once fully loaded, these heavy trucks must navigate the rough terrain of the fields to bring their cargo to the road. Time is of the essence, as the sugar content begins to degrade the moment the cane is cut from its roots. The journey from the organic chaos of the farm to the structured precision of the factory is a vital logistical challenge. Upon arrival, every truck is weighed and logged, ensuring accurate tracking of the raw material entering the massive processing facility today. Hydraulic lifts tilt the containers, sending tons of raw cane cascading down onto the receiving tables to begin the processing cycle. The factory floor rumbles as the raw material enters the system, moving steadily towards the first stage of cleaning and preparation. Before extraction can occur, the cane must be thoroughly washed to remove field mud, rocks, and other unwanted external impurities. Clean water is essential here, stripping away the dirt to ensure that only the plant material moves forward to the crushers. The cane is then fed into heavy-duty shredders, which tear the stalks apart to expose the juice-bearing cells inside the fiber. This preparation step is crucial, as it allows the subsequent rollers to extract the maximum amount of sucrose from the plant. The shredded cane enters the milling train, a series of heavy rollers that apply immense pressure to squeeze out the liquid. Raw juice cascades from the rollers, a sweet but murky liquid that contains the sugar we seek, mixed with many impurities. The leftover fiber, known as bagasse, it is not discarded but is collected to serve a vital purpose for the factory's energy. This dry biomass is burned in massive boilers to generate high-pressure steam, making the sugar mill largely self-sufficient in energy. Meanwhile, the raw juice is pumped away for processing, starting a complex chemical journey to purify it into a clear syrup. Quality control technicians constantly monitor the acidity and sugar concentration, ensuring the raw material meets the strict standards required for refining. To neutralize the natural acidity and trap impurities, milk of lime is added to the juice in large heating tanks. This chemical reaction binds with proteins and other non-sugar solids, causing them to coagulate and become easier to filter out. The mixture is then heated to near boiling point, which accelerates the clarification process and kills any naturally occurring bacteria present. In the clarifiers, gravity does the work. Heavy impurities settle as sludge at the bottom, leaving clear juice at the top. Even the sludge is processed through rotary vacuum filters to recover every possible drop of sugar before the waste is discarded. The result is a clear, golden liquid, significantly purer than the raw juice, but it still contains far too much water. The juice enters the evaporation station, a series of vessels designed to boil off the water content under strictly controlled pressure. As the liquid moves through these stages, water is removed as steam, which is often recycled to heat the next vessel. The liquid gradually thickens, losing volume but gaining density, transforming from a thin juice into a rich, concentrated sugar syrup.
Pressure is spiking
Precise
again.
control of
We're
temperature and
almost in the
vacuum
red
pressure
zone.
is
I see it.
essential to prevent the sugar
Vacuum
from
is
burning or
holding steady for now.
caramelizing during this intense heating. By the end of this stage, we have a heavy syrup containing about 65% sugar solids ready for crystallization. The syrup is pumped into vacuum pans where it is boiled at lower temperatures to prevent discoloration while driving off more water. To start the crystal formation, microscopic seed crystals are introduced into the supersaturated syrup, acting as anchors for sugar growth. In a process of controlled growth, the sugar molecules in the syrup latch onto these seeds, slowly building up into visible crystals. Operators watch through sight glasses, carefully managing the boiling rate to ensure the crystals grow to the exact desired uniform size. When the crystals reach the right size, the mixture, now called massacuvite, is discharged into holding tanks called crystallizers. Here, the mixture is stirred slowly while cooling, allowing the crystals to absorb a little more sugar from the surrounding molasses. The final separation happens in the centrifuge's high-speed spinning baskets that work like the spin cycle of a washing machine. The baskets spin at thousands of revolutions per minute, forcing the heavy liquid molasses to pass through the fine mesh screens. The dark molasses is flung out, leaving behind the raw sugar crystals, which are trapped against the walls of the basket. A quick spray of hot water washes the crystals as they spin, removing the last traces of the brown molasses coating. What drops out of the centrifuge is damp white sugar, now separated from the impurities, but still containing too much moisture. The separated molasses is collected and sold for animal feed, fermentation, or alcohol production, ensuring nothing goes to waste here. The damp sugar crystals travel along conveyors to the drying station, where the final moisture content will be carefully reduced. Huge rotary dryers tumble the sugar through a stream of hot, filtered air, gently evaporating the remaining water from the surface. Inside the drum, the crystals are lifted and dropped repeatedly through the warm air current, ensuring every grain is dried evenly. After drying, the sugar must be cooled down to room temperature to prevent the crystals from clumping together during storage. Vibrating screens then sort the crystals by size, separating fine dust and oversized lumps from the standard granules we use daily. The result is the refined white sugar we recognize, uniform in size, free of impurities, and ready for the final journey. The finished product is stored in massive silos, sometimes holding thousands of tons, protecting it from humidity until it is packaged. In the packaging hall, high-speed automated machines take over, forming bags from rolls of plastic film with incredible precision. Electronic scales weigh the sugar instantly, and dropping the exact amount into each bag before it is sealed shut by heat. Robotic arms stack the finished bags onto pallets, working tirelessly to prepare the product for distribution to supermarkets and manufacturers. Forklifts move the pallets to the warehouse, a cathedral of sweetness, where the output of the entire season is stored. From here, the sugar is dispatched globally, becoming a key ingredient in everything from morning coffee to complex industrial recipes. It is a remarkable transformation, turning a rough, dirty grass from the field into a pure, standardized chemical used worldwide. Beyond the home kitchen, this sugar fuels the beverage industry, adding sweetness and texture to the drinks we consume daily. In bakeries, it provides not just taste but structure and color, playing a crucial chemical role in the art of baking. The modern sugar mill is a triumph of engineering, optimizing every stage to minimize waste and maximize the yield extracted. Engineers and scientists work constantly to refine these processes, seeking ways to use less energy and water for production. Environmental responsibility is key. Water used in the process is treated and often returned to the fields for irrigation. Back in the fields, the cycle continues. New shoots emerge from the soil, beginning the long journey toward the next harvest. Agriculture and industry rely on each other, a symbiotic relationship that sustains rural economies and feeds the global supply chain. The sugar industry is efficient, producing not just sugar, but also molasses, organic fertilizers, and renewable electricity from the waste. Automation plays a massive role today, with central control rooms monitoring every valve and pump to ensure perfect consistency. Human expertise combined with digital precision allows these factories to run 24 hours a day during the crushing season. As night falls, the factory remains awake, a beacon of industry processing thousands of tons of cane. Before sunrise comes, the logistics chain never sleeps, ensuring that the fresh cane is processed immediately to prevent the loss of sugar content. This relentless pace is necessary to handle the massive volume of the harvest within the limited window of the season. At the molecular level, we are simply isolating sucrose, a pure carbohydrate that provides quick energy for the human body. From ancient times, when sugar was a luxury spice, we have reached a point where it is a global commodity. Technological advancements have democratized this product, making what was once white gold accessible to everyone around the world today. Ships loaded with sugar traverse the oceans, connecting the tropical fields of production with consumers in every corner of Earth. Few consumers realize the immense effort, the heavy machinery, and the precise chemistry required to put that bag on the shelf. It is a process driven by heat and fire, transforming the energy of the sun captured by plants into fuel. The transformation from green juice to golden syrup, and finally to white crystal, is a masterpiece of industrial chemical engineering. Under the microscope, the chaotic organic world vanishes, replaced by the perfect, sharp geometric order of the sucrose crystal lattice. Strict quality control ensures purity, removing potential contaminants to deliver a safe and consistent product for global food standards. As the sun sets over the refinery, the hum of the machinery continues, a testament to human ingenuity and industrial capability. The empty trucks depart, their job done for the moment, leaving behind the raw material that will feed the factory tonight. It is a simple ingredient, yet its production creates a complex web of agriculture, logistics, engineering, and global economics. So the next time you sweeten your tea or coffee, remember the journey from the muddy field to your cup, from the soil to the stalk, through the crusher and the crystallizer. It is a journey of refinement and purification. It relies on the hard work of farmers and the precision of engineers working together to sustain this massive industry. Sugar connects us all, a universal source of energy and pleasure, found in cultures and cuisines across the entire planet. Thank you for watching this sweet journey on Dystopian Bot Rise. Subscribe now to discover more secrets behind everyday industrial marvels.